Section 1.3, example 18, using the fundamental theorem and the chain rule to calculate derivatives. So let big f of x equal the integral from 1 to the square root of x sine t dt. So we're looking for f prime of x. So we're looking at the derivative with respect to x. So let's do the same thing that we did in the previous example. Zoom in a little. So we have capital F of x is equal to the integral from 1 square root of x sine t dt. And we're looking to differentiate with respect to x. Again, we're looking to differentiate with respect to x. The left side, it's just df dx, or you could think of it as like f prime of x. On the right side, however, so when we differentiate with respect to t, it's just going to be sine t, but here we're differentiating with respect to x. Again, we have that value over on the right side, but the derivative of a constant is equal to 0, so we could ignore that part. This is where we have a little tiny bit of a problem. So when we differentiate that function, it's still just going to be, so the derivative of an integral is the function. Again, the derivative of the integral is the function, but we still have to look at the inside of that function too. We still have to look at the chain rule part. So here what we have is sine of t, actually not t, sine of square root of x plus or times the derivative of that inside part. So I'm going to write it like this, the square root of x prime. So we still have to take the derivative of this part right here. So we have sine root x, but now we have to take the derivative of what we had on that inside. So what is that? X to the power of 1/2, 1/2, x to the power of negative 1/2. So simplify this, we end up with 2 root x in the denominator. That's this part right here. Numerator, we have sine of root x. And there we go. If you have any questions, please feel free to ask. Otherwise, bye.